Hi, and welcome to Math 1300, Nunez Community College. This section is 2.4. It's writing and graphing equations. The first thing that we have to know is when writing an equation, we're going to write it in a form that is known to everyone. The first form that we have is going to be slope-intercept form. Slope-intercept. Slope-intercept form is named that because it gives us the slope of the line, which we refer to as the slant, and the intercept, which is the y-intercept. The slope-intercept form of a line looks like y equals mx plus b, where m is the slope of the line and b is the y-intercept. The y-intercept, which means where it crosses the y-axis. Now, this is what we have to have. This is the slope-intercept form. And if we move to example number 1, it says write the equation of the line having a slope of 2 and y-intercept of 3/5. So it says write the equation of the line having a slope of 2 and a y-intercept of 3/5. This is nothing more than plugging it in. Slope goes here, so we're putting the slope in for m and the y-intercept for b. So we will look at this and write it as y equals 2x plus 3/5. This would be the equation of the line having a slope of 2 and a y-intercept of 3/5. We have different forms of the equations. This is the slope-intercept form, but that's not the only form. We also have a standard form. A standard form. This is the standard form of an equation of a line. It would be ax plus by equals c, the standard form, where a, b, and c would just be coefficients. So again, an example of the slope-intercept form, y equals 2x plus 1, where our slope is 2 and our y-intercept is 1. An example of the standard form would be like 2x plus 3y equals 6, where a, b, and c are nothing more than coefficients. For example number 2, they're going to give us the equation in standard form, and they're going to want us to write the equation in slope-intercept form and then give the slope and the y-intercept. Give the slope and the y-intercept. So they're going to give us the equation, which is going to be 2x plus 5y equals 25. 2x plus 5y equals 25. And again, they want us to rewrite it in slope-intercept form first. So in order to do that, we're going to isolate y, because it's y equals mx plus b. We're going to take what's not with the y, bring it across the equal sign. So that gives me 5y equals negative 2x plus 25. Bring the 2x to the other side by subtracting it. Now we're going to isolate y, so I'm going to divide by 5. I'm going to divide by 5. Canceling them out, and y equals the 5 is the denominator for the 2, and the 5 is the denominator for the 25. So that's going to be y equals negative 2/5 x plus 25 over 5. Well, 25 over 5 is 5. 5 times 5 is 25. We wrote it as slope-intercept form, and now when they're asking for the slope, we know that the slope is negative 2/5, and we know that the y-intercept is 5. Okay, if we have lines that are parallel to each other, we talked in a different time or a different section about parallel lines. Parallel lines is written with the number or the looking like an 11, okay? That means two lines that do not intersect. And parallel lines not only don't intersect, but the reason that they don't is because they have, this is line 1, this is line 2, they have slopes that are the same. Up the same, over the same, up the same, over the same. So if my slope for the first one might be 2/3, my slope for the second one would also be 2/3 if the lines are indeed parallel. Lines that are not parallel intersect, but if they intersect in a particular way, they could be called perpendicular lines. Perpendicular lines. Perpendicular lines, again, we said it was an upside down T that we used for perpendicular. There are two lines that intersect and intersect at 90-degree angles. Perpendicular lines, if I have two lines like this, they make 90-degree angles. And we know that if this is line 1 and this is line 2, we know that their slopes have to be opposites. This one's going uphill, this one's going downhill. So this one is positive, that one is negative. Not only are the slopes opposites, but the slopes are opposite reciprocals. Opposite reciprocals. So if this one going up happened to be 2/3, then this one going down would be negative opposites, 3/2 reciprocals. So again, parallel lines, two lines that don't intersect, have the same slopes. Perpendicular lines intersect at 90-degree angles. They have opposite reciprocal slopes. Opposite reciprocal slopes. We did talk before about lines that are parallel and lines that are perpendicular as far as finding the slopes. One more time, I'm going to make sure that we got that. So I'm going to say that if we had the slopes of particular lines, which is M, I want the slope of the line parallel to that and the slope of the line perpendicular to that. So if I have a slope of 3/5, I want the slope of the line that's parallel to that. It would also be 3/5. If my slope is 3/5, the line that's perpendicular to that would be -5/3. Let's go ahead and fill in a couple of more. Suppose I have a slope of -1/4. Suppose I have a slope of 7. And suppose I have a slope of -2. Parallel, the same, -1/4. Perpendicular, opposite reciprocals, 4. Parallel, 7. Perpendicular, opposite reciprocals, -1/7. -2, parallel would be -2. Perpendicular would be +1/2. Again, just showing you the differences between lines that are parallel and lines that are perpendicular. Now we're going to write an equation of a line, and it's going to not have all the information that the last one did, where it gave us the slope and the y-intercept. So we know that the equation is going to be y equals mx plus b. That's our final answer. But in order to get there, we have one formula that we can use. It's called the point slope formula. The point slope formula. The point slope formula is a formula for writing equations of a line, and will end up in slope intercept form. The point slope formula is y minus y1 equals m times x minus x1, where m is the slope in the point slope formula, and x1, y1 is the ordered pair, or the point in that point slope formula. So it says, write the equation of a line passing through point 2, 1, passing through point 2, 1, with a slope of 4, well, again, point slope formula, we have a point, we have a slope, we can fill it in. So this is going to be y minus the y coordinate. The y portion is what? 1, so y minus 1 equals the slope m times x minus the x coordinate, which is minus 2. Once we've written it, it obviously is not in slope-intercept form, so we must clean it up. We must do the operations it's asking us to do. So the first thing is to distribute the 4 to both of these, giving me y minus 1 equals 4x minus 8. And next, we have to have slope-intercept form, so y equals, bring the 1 away, y equals 4x. In order to bring it away, I'm going to add 1 to the 8, so negative 7. Y equals 4x minus 7. And again, it's in slope-intercept form, but we use this formula. It is the only formula we have for writing equations of lines. Now, they could get a little tricky on us, and they could say something like, write the equation of a line passing through points and give us 2 points. This is the next example. Write the equation of a line passing through points 1, 2 and 5, 6. Passing through points 1, 2 and 5, 6. Well, we have a point slope formula and we're fine with the points. We can use this point or that point. We're fine with the points. Problem is we don't have a slope. So what we have to do here is try to find a way to get the slope. And we know that if we have 2 points, we can find the slope. Slope is going to be what? y2 minus y1 over x2 minus x1. So we can actually find a slope. Then use that slope with one of the 2 points. So that's going to give me what? y2, so it's going to be 6 minus 2 over 5 minus 1. 6 minus 2 would be 4, 5 minus 1 would be 4, so my slope is 1. My slope would be 1. So we're going to plug a 1 in here, and we're going to choose one of the 2 points. I'll pick the first one. It seems like it's easier. So that would give me what? Y minus 2 equals 1 times x minus 1. Now I do what we have to do and distribute, but by multiplying by 1, I don't change anything, so it's just x minus 1, and then what? Bring the 2 to the other side by adding the 2, y equals x plus 1. This would be the equation of the line passing through those 2 points. That was the last example for section 2.4. I'll catch you at the next one.